said so far was intelligence. Just kidding. Okay, so let's design this as has many belongs to, right? So which do you want to do? Table has many clients or clients have many tables? Okay, so we'll say a table has many clients, and he wants the other side to be belongs to table, right? Okay, so if it has many and belongs to, a client can only belong to one table, and tables have many clients coming to them. So you believe in a world where many people will go to the same table, but each person can only ever go to one table in their life. So let's map that out. So if a client belongs to a table, a client must have the foreign key for the table, right? So just that's the de facto thing. If something belongs to something else, it has the foreign key for that thing forever and always. Okay, so we have a table ID, and we'll give it a name. So you and me, Sam, we are diners. What restaurant would you like to go to for the only restaurant you'll ever attend in your life? Pizza Hut, Domino's, or Bouvet? Pizza. Okay, you're going to Pizza Hut. So Pizza Hut has tables 1 and 2. So you're going to table 1 at Pizza Hut. I like Bouvet. I'll go there. So my point is, to me, it becomes very obvious when I say a client belongs to a table. I'm stuck at the table that I belong to. I can never, ever go anywhere else. And this immediately feels wrong, right? Where the only other way that I could say that you're going to go to another table ever in your life is if I write you down again, which I can never do if I don't want to duplicate stuff, right? So now you want to go with me to Bouvet. Cool, Bouvet has table, what? Table 3. Okay, cool, you come with me to Bouvet. Sorry, so I went to Bouvet too. And now, like, let's say clients actually had like a whole bunch of attributes about them, right? You have like a height and an IQ, right? So you're like 6 feet tall and you have like 110 IQ, and I'm like 6'1" and like 150, right? So every time you dine, I have to write down how tall you are and how smart you are, and if at any time you got smarter, which I'm hoping is a possibility, right? Every time you dined, right, you'd be in here, right, like 1,000,000 times, right? And if you ever changed, I have to go and update every single row, right? Now you're as smart as me, and I go through my database and I say, Sam's a different person now, he's so much smarter, he's so much cooler, blah, blah, blah. So I never want to have to repeat stuff, right? So we're going to get rid of all this, right? So it's not that you, not that we're going to repeat you, and it's not that you can only ever dine at one place. I would like that you can go to many places, and many places can also accept many people. So it's not has many belongs to, it's has many and has many. Both sides have many.
So what I wanted to ask was, like, this is a situation where it's like a many-to-many relationship where it's like 2 tables, right?
It's 3 tables.
It's 3 tables.
You can never have many-to-many with 2 tables because of what we just played with. So we have to have, so there's just no other way. Like, so we experimented with having people only belong to one thing, right? We experimented with writing down their name a bunch of times. So the only way to solve the problem of a many-to-many where you only use 2 tables is you end up repeating people, which is not a good solution. So it's possible, but it's a bad solution. So if we have many-to-many, we need 3 tables. Otherwise, we end up repeating information. So what we do is we create this intermediate table that we call a join table. And we say, rather than keeping track of who's dining here and at what table, there's going to be a table that just keeps track of who's the person and where are they. And that's all it's going to keep track of. Its job is to capture this relationship between the 2 things, this intermediate object. So I want to keep track of my client ID, excuse me, and my table ID. So now when you dine, we put you in the reservations table. We don't ever touch you and we don't ever touch the tables because these things just exist and they never change. The thing that's changing is there's this intermediate thing that's like happening that's keeping track of who is pairing off with what. So now we can have tons of reservations, right? You want to dine, that's you, right? You're going to go to your favorite restaurant, Pizza Hut, right? Then you're going to go to Pizza Hut. You're going to go to a different table tomorrow. Then you're going to go back to your favorite table, the first one, right? Then you're going to go back to the other table, right? And like maybe most of the time, you know, they keep that table in the corner just for you, right? And you're like, table one's my thing. They just like hold it for you, right? And this is you going to Pizza Hut a whole bunch of times. You sometimes go to the other table when it's not ready, right? But the vast majority of the time, you just sit at table one. And now, right, like if you get smarter, we can just change you in one place, right? We don't have to alter a whole bunch of rows because these are just IDs pointing to the entity that is Sam. And we never have to change Sam himself. And that's the whole point of the join table. And the same thing with the table. Like if there was a whole bunch of things we had to keep track of about the table, it just points back to the table. And so we, you know, if we ever changed the table, this thing just points to the table and we would just change it in one place rather than like on every record of the join table. Additionally, like sometimes the reservation object may have other things that it keeps track of. Maybe like a reservation has like a date time, right? So you keep track of where it's pointing and when it's happening. Maybe you have a price, right, that the diners paid. Maybe you want to keep track of like what they ordered, right? So maybe you have like a food ID. And then we have a food table. And in the food table, right, you just have like an item name. So it's like hamburger, cheeseburger, right? So now we keep track of like this reservation, and this is like a silly way to keep track of what people ordered, right? Because, so this happened today, right? The price was $100, and you can only order one thing, right? Yeah.
Just so, like, ignoring the fact that it's silly because you can, like, only order one food item.
Yeah.
Now, client ID, table ID, and food ID are all has many relationships.
You're saying client so yeah, client would have many food through
this joint
the reservation table, yeah.
And then table, same with food, and then food would have many tables and have many clients. So you can make like basic question is like you can have a joint table where multiple things are being joined, not necessarily just one word.
Yep. Yep. And I'm trying to illustrate a case where that might make sense. So probably you'd want even another join table between like reservation and food. That would be like meal or something, and it'd be like what was the list of things that we ordered, and that's a join between the food and the reservation, right? And then maybe you have like a check table, right? And then you could join to that, and like you kind of just keep expanding as you need to keep track of new stuff. And to me, it's like the most obvious, again, to do it all in here, because the minute I wrote food ID, I was like, this doesn't make sense, right? I can only have one thing for my meal. This is silly, right? It's really a many-to-many relationship. Reservations have many food items. That's obvious, right? And food, hopefully, can be ordered by more than one person ever, right? So again, it's obvious that it's many-to-many. This schema falls apart. So I would need an intermediate table called probably like meals or orders or something like that. That was a join table. All right, so that's how I would do it. All right, so reservation, table, restaurant. I think that's it. So I'll just write out the associations real quick.
Can you go through, like, let's say I want to know how many reservations on my restaurant?
How many reservations your restaurant has had? Yeah, so let's write out the associations now. So for me, once I get this down, doing the associations are super easy. So the first thing you can do is anything that has a foreign key is just belongs to. So tables belongs to restaurant. Restaurant is nothing on the belongs to side. Client is nothing on the belongs to side. And now, oops, reservations belongs to client and belongs to table. Okay, so now we have all the belongs to. Let's do the has many. So has many is the only one that's like kind of not required. You need the belongs to if you're going to go through that table. But everything else is kind of optional if you want to be able to ask this object that question. So the associations define the methods that allow you to auto-generate SQL. So if you're going to want to be able to ask an object questions, so like Amr just said, I want to be able to ask a restaurant object, what are all the reservations? So I need to start writing my has many associations. So has many reservations, right, directly. Sorry, not directly. So I want to be able to say has many reservations, but there's no direct relationship between a reservation and a restaurant, right? If there was a direct relationship, there would have to be a restaurant ID in the reservations table. So we talked earlier about how like we could put the reservation ID, the restaurant ID here, and that would be a duplication of data, but it would allow us to have to do less joins. So we can say has many reservations, but only if we say has many through something, right? So the only way a restaurant knows about its reservations is through this intermediate table, right? Because a restaurant knows about its tables, and tables know about their reservations. So I can say a restaurant has many tables, right? And then I can say a restaurant has many reservations through tables, right? And the order of this matters because when you define this association, when you try and talk about it through something, Rails is assuming that there is an association that has been defined already called tables. And you'll get an error that says, cannot find constant restaurant : tables if you haven't done it in the right order. So you have to say has many tables, you define that association, and then you can tell active record, hey, and I have many reservations through that association that has already been defined. So now I should be able to say like restaurant equals restaurant dot first, and then I should be able to say rest dot reservations, and that should give me an array of all of the reservations that have been made at my restaurant. All right, so that's that. Also, tables has many reservations, right? Clients has many reservations, right? And these are easy because just when you speak them, to me, they sound obvious and semantic, and that's kind of the point. But in case you're curious, if a reservation belongs to a client, then a client must have many reservations, always and forever. So if you get confused, you can always start by just saying, let me do all the belongs to first, because I have the foreign keys, and then I have to do the opposite side of those. So anyone that belongs to somebody else, that person must have many of that thing. Bruno? Yep, so I should be able to make reservations at a bunch of different restaurants. So this is Sam going to Pizza Hut to 2 different tables a bunch of times, but right, like I could add myself. So now Blake's making a reservation, and I'm going to go to Buvette, which has table number 3.
So we can think about this in like an account, right? Like since I would build a table account, just think of
Yeah,
all this communicates.
absolutely. Yeah, I often will think of the UI and be like, what are the questions I would want to like answer? What are the screens I'd want to display to you? You'd certainly have a page that's like /reservations, and it would show you all of Bruno's reservations, right? And you'd probably want to be able to filter by what are all my reservations at Buvette, right? How many times have I been to like different restaurants, and like all the questions you want to answer. And then since you don't like writing SQL, not you, but all of us, right? Then you'd want to draw the association so that I can just call dot reservations rather than calling dot find by SQL select all from reservations, where like, so it's like every time I want to ask the database a question and I don't want to write SQL, I should have an association. Cool, so clients have many reservations. Tables have many reservations. Reservations just belong to things. And then clients should also have many what? They should have many tables through reservations, right? And they should also have many restaurants through tables. So I always think of this as kind of like crawling across. I think of it like visually. So I'm like, I know I can get to reservations because I have this direct association. I know a reservation knows about the table, so I can get to the tables. And then I know tables belong to restaurants, so I can kind of like crawl across all of these tables, continuously just joining on the more information that I want. So anytime there's like a direct relationship between two tables, if I can get to one table and that table can get to the next table, like I think sometimes it's like objects talking to each other or students, right? And like if like Lewis is in charge of keeping track of reservations, I could say, Lewis, like tell me all my reservations, and he's like, okay, you have reservations at table 1, 2, 3, and 4, and then I don't keep track of tables, but if you ask Gil what restaurants those tables belong to, then Gil knows that, and he could ask Gil, and then Gil could ask Brian for those restaurants, and then Brian will be like, here's those restaurants, and now between the 4 of them, I have all the information that I need. But if anybody doesn't have a direct link to the next table, then I'm stuck, right? And that's the whole point of these keys. These keys say, this record points to the next table, and here's how, right? So as long as like everybody has a key that points to the next person, we don't have to keep everything in one table, and everybody just needs to kind of know like a little bit and know about like kind of the next person in line. And that way we avoid duplication. Yeah, I mean, that's what I kind of was trying to get at earlier when I was talking about like the highest level objects. Lewis, I think, described it better by talking about like more parent-child relationships. So like, I think of the restaurant as being this thing that's very much the parent and the child, and the client also being very much a parent. So they're kind of like sitting on these outer ends, and like we're never going to change them, right? A restaurant is a restaurant. It's not going to change. Right? A client is a client, and then like they're going to kind of like restaurants are going to have this like expansion where it's like restaurant has many tables for sure, right? So then to me visually, I'm kind of thinking like clients are out here and restaurants are here, and now like I'm moving inwards and I'm like, okay, definitely there's a has many relationship. Like tables, there's going to be a bunch of them at each restaurant, right? And so a restaurant can like manage that. And then I have clients over here, and I definitely know clients need to be able to eat. So like I'm gonna move in from clients towards the thing that I want to eat at, which is the restaurant. And so I'm like, okay, there's got to be some kind of thing that tells me a client ate at a restaurant here. And if we didn't have this idea of tables, it would just be this 3 tables, right? It'd be restaurants, clients, and a reservation. And a reservation would just be at a restaurant, right? But we have this intermediate table that we're like, actually, it's not just that like we're keeping track of that you ate at a restaurant. We want to be even more specific. So now we have clients over here, we have restaurants over here, and then we gradually like move towards clients by saying first we have lots of tables at the restaurant, then we have people eating at those tables, then we have like the clients over here. So the client and the restaurant don't need to really know very much. They have, I mean, when you look at their tables, they just know about themselves. And the other people need to keep track of like the restaurant and the client. And so they're responsible for like keeping track of more stuff. All right. Let's move on to the harder one. All right, we probably don't have enough time to go through it the same way we just did. So I'm just going to talk through how I thought about it, and you guys know what you did. But I would encourage you to go through the same exercise that I did with your code. See if you can make libraries with books and authors, and if it starts to break down, hopefully that's an indicator that your service, your schema doesn't necessarily support what you'd like it to support. And I'll even point out some stuff that I noticed when I was going through this before that like I think Katie missed a little bit when she was doing this. Am I on the canonical? I'm going to go to your one. All right, I'll just make a new one of these. And I'll share this with you guys. All right, so I'm just going to take these. I'm going to put them into my spreadsheet just the way I did last time. So I have country, can do. Not working, whatever. So I have country, library. Oh, this. Oh, also this is supposed to be county, not country. I don't know if that was confusing. Member, book, author, checkout. I'm gonna get rid of topic because I think it's confusing. Superfluous. And genre. Okay. So again, going with this idea of like what's the parent object, to me the parent object just feels like county. Like it's like the highest level thing. County is clearly going to have like multiple libraries. It feels like the parent object, the God object, however you want to think about it. I put it on the left because visually, like that to me, we're going to have like this expanding set of data. So let's say a county has a name. So we have like, let's call it like Kings County and Queens County. Right, and that's Brooklyn and Queens. So I imagine there's going to be more than one library in each county. So I'm going to give them an ID, and I'm going to give them a county ID. And I'm not going to give them, well, I'll give them names. Maybe that'll make things more clear. So this is going to be a Brooklyn library. We'll have 2 libraries in Brooklyn and 2 in Queens. We'll call this Cobble Hill Library and what is it called? No, that's Queens. We'll call it Brooklyn Heights Library. And then somebody give me 2 in Queens. Does anybody live in Queens? Queens Library. Anything else? Sunnyside Library. Cool. So also it feels to me like members are going to be kind of like a parent object. And members are going to like be checking books out and like all that sort of thing. So I don't feel like they're going to really belong to anything. But maybe actually members are going to belong to like libraries, right? Like when I get a library card, I gotta like denote that some way. So here's like where I would have like my first question, which would be, okay, like can people have library cards at multiple? It's what? Oh, yeah. Okay. We'll deal with that in a minute. So can people have library cards to multiple libraries? Yes.
I mean, wouldn't it be like one library card works with a lot of libraries?
No. If you go to like Connecticut to the suburbs and you show them your New York City library, they're gonna be like, fuck off.
Right, but then wouldn't we need another parent that's not county? I guess the question is, if I go to Queens with my Brooklyn library card, does it work? I think it does.
No, it doesn't. It works in your borough though.
Oh, okay. I mean, I guess if we're differentiating counties, then we should differentiate libraries.
So I got to look at the specs, right, and say, okay, I know how the real world works, but let's imagine however we want to design our app. So Katie says counties can have many library members. That seems obvious, right? But as a member, we don't really specify whether or not you could be part of multiple libraries. So I'm going to assume that she wanted to keep it simple, and as a human being, I can only like live in one place, and I can only belong to one library member. And what I noticed was she writes, members have a county. So she's not even really associating people to individual libraries, which is how I would have done it. And I would have said people can belong to multiple libraries, and I would have had a join table in between libraries and members, and I would have done it like this. I would have called it like library member. I would have said there's a member ID, and there's a library ID. And so this is me belonging to two libraries, right? I'm going to belong to Cobble Hill and Brooklyn Heights. And that's me, right? And I'm Blake. And we could have Lewis, and he could belong to 4 libraries or whatever, right? So this is Lewis. He belongs to one in Queens and one in Brooklyn because he loves traveling and reading. So this is how I envision it. But that's not the world that we are put into. We are put into a world where you live in one place and you have one library in the place that you live in, and that's what you get.
Sort of like, isn't sort of library in a way can be used sort of like a joint table?
Say that again?
Can't library itself in a way be used as like a joint table? Because like can't you say that like your county has members through the library?
Your county has members through the
Your
library.
library has members and your library has a county. So if I'm a member, can I find out what my county is? Like if I'm a county, can I find out what my members are through the library? Since the library already has an ID for that and an ID for county.
Yeah,
So it's sort of
definitely.
like
So
a
a county's
joint
going to have many
table.
libraries, and a county's going to have many members through the libraries, for sure.
So is that like a valid thing? Like I can say like.
Yeah, I mean, I wouldn't call this a join table. I would call it kind of like a regular table. Typically, I think of a join table as being something that has 2 foreign keys that point to 2 other things, and doesn't really do much else. This is like a situation where like library is really like a real entity in our system. Counties are real entities in our system, and members are real entities in our system. But we do happen to be able to say counties have many members through libraries.
So you would, in this scenario, it doesn't make sense to create like a completely separate table. You can just go through libraries.
Yeah. So in our world, the way that we work out like what libraries you're a member of is we say counties have many libraries, and as a member, I'm a member of a county, and I guess in our world, I get access to all of the libraries in Brooklyn if I live in Brooklyn, right? And that may be how the library system works. It may not be. I don't know. But that's what we wrote in the spec, right? And again, like my point is that it's all arbitrary, right? Either we're designing the system in such a way that it only works in that way, where we're just saying, hey, like you person, because of how we want to like store stuff, you get access to all libraries automatically when you move to a new county. To me, that's not the most sensible way to do things, but that's kind of like what we're describing in this spec. So a member belongs to a county, so I have a county ID, right? And I can only live in one county, and I can only have access to the libraries in that county. So I have a county ID. So I live in Kings County. Lewis lives in Queens County, let's say. Cool. So libraries also have books. This was another one that I thought was kind of weird, the language that we used. So books usually live in one library. So what did that mean to you guys? Okay.
I guess what you're saying is like the issue is, are these individual books like a particular physical book, or is this like an ISBN number book, like a figurative book? Like this is the idea of a book.
Yeah.
And so I don't remember how I did it.
Yeah, so this is super confusing, I think. The term usually, I think, is very confusing because I don't care what usually happens. I only care what's possible. Now, if it's a has many belongs to relationship between books and libraries, that means that if it was has many, if clearly libraries have many books, right? That's obvious. The question is, do books have many libraries or do books belong to a library? Well, if books belong to a library, that would mean like the ISBN for Harry Potter, right? One library in the world gets to purchase that book, which probably feels wrong, right? So that's a book belonging to a library, right? If we write that table, it has to be, if a book belongs to a library, right? We'd have a library ID for that book. We'd have a name for that book, right? ID 1 belongs to library 1, name of the book. So this is Harry Potter, book 1. So here, Harry Potter can only belong to one library in the world, right? It happens to belong to the Cobble Hill Library. I'm so lucky. But that feels wrong,
You can
right?
have multiple Harry Potters. You can have multiple records with different.
So where would I put those records?
Just right below the last one.
Okay, so this would be ID 2, library 1.
Well,
Sorry, yeah, library 2. Right, so this would be.
I think that's how they wanted you to do it, right?
Uh,
Well, you can have, so it's not like Harry Potter only belongs to the library, it's just that particular book.
well, when I read the answer is she has books belonging to a library, which implies that you'd have a library ID and you would be repeating everything about the book
Right.
every time another library purchased it, which is not the normal data structure.
Do you think in the real world you would just have like, I guess you'd have another table called like titles, and then those would be like the ISBN.
You'd have a join table between books and libraries, which would keep track of. Let's do it. Okay, so this is the model of the world. If a book belongs to a library, we must be designing the schema like this, where we say, okay, a book has the foreign key for a library, right? And every time Harry Potter wants to be owned by another library, we have to repeat it, right? And so I'm making the point that I made to Sam that if we do it like this is fine. But let's say books have other attributes like number of pages or date released or like a whole bunch of things like that, right? Every time a new library gets this book, I have to copy all of that data. So this is, we're describing really a has many relationship, but we're putting it in the database as if it's a belongs to relationship. What we need is a join table. So what would a join table look like that would be better than this? Let's make that. So now we have like a table called book libraries, and hopefully I could come up with a better name than that. And all this is going to do is going to say book ID and library ID. It's just a join table. So now Cobble Hill Library wants to get Harry Potter 1-1, right? Brooklyn Heights wants to get Harry Potter 1-2. Queens wants to get Harry Potter 1-3, 1-4. So now we're not repeating data, we're just keeping track of which library has this idea of a book, Harry Potter. And now I don't have to repeat Harry Potter all of these times. I just need one record that says Harry Potter is book 1. I can get rid of this library ID. And then if I had all these other attributes like number of pages, date released, all this stuff, again, I would never have to repeat this data.
This is basically your like physical copies.
Yes.
Is that a good name?
Let's call it that.
And then this table could house stuff like the condition of the book.
Sure,
whether
absolutely.
it's hardcover or paperback.
Absolutely. Absolutely. So in my view, like books have many libraries, libraries have many books. Otherwise, if libraries belong to, if books belong to a library, we end up duplicating data, or we end up in a world where only one library could own one book, and books exist as this like one physical entity that can only ever exist in one place at a time. All right, what else do we have? Okay, so Katie says author. What's the relationship between authors and books? Authors write at least one book, but usually more, and authors have a name, and books have at least one author, and books have at least one genre. So what does that look like? Again, this is a many-to-many relationship. Books have many authors, right? And authors have many books. So let me get rid of these two columns. And I need a join table. So I'll call this book authors. So let's say we have J.K. Rowling, right? And Stephen King. I don't want to duplicate data about them. All I want to do is capture the relationship between who's writing which books. So I have this book, and I have a book authors. So book authors just points to the two other tables that it's joining. So Harry Potter is just written by one person, right? J.K. Rowling. So author 1, book 1, and Stephen King. Does he ever write with any other authors? So let's do this. Freakonomics was Stephen Levitt and Stephen Dubner, I think their names are. So Freakonomics has two authors, right? Author 3 and author 4, and they both wrote the same book, book 2, right? So again, many-to-many relationship, we need a join table. Books have many authors, authors have many books, and they have it through book authors. Same thing happens with genre. I won't build that out. Books have many genres. Genres have many books, right? So we would need a book genre table that would just point out to both of those guys. Checkout is an interesting one. So checkout, again, like all of this stuff really is kind of like seeding the data with the exception of libraries buying books. So we kind of like seeded the data, and then we said, okay, what books actually have been like bought and like allocated to which libraries? So that was this table here, right? Physical copies of books getting distributed, we kept track of in this table. Everything else was kind of seed data, and now this is the other like table that's going to keep track of like things happening, right? So now we have people, we have libraries, we have books they can rent, and now people are going to actually use the system, and we're going to rent them books. So for a checkout, I think we need a couple things. What are the important things that a checkout needs to know about? A book for sure, right? Which book got checked out? So we're going to have a book ID. Who's checking it out, right? So we need a member ID. Anything else? Date, right? So what dates do we need? So we need a start date, right? What day did you rent it? What day did you return it? Right, so, or what day should you return it? Due date. And then you need some kind of third column, probably, or something else going on here, right? Because really you have like a start date, you have a date it should be returned, and then you probably want to keep track of when it actually was returned, right? So I'd say return date Katie didn't have that in her solution, and so I don't know if she mentioned what she had mentioned in the checkout thing, but this is my own opinion.
You also need the county?
No, that's a great question. I can figure out what county because I know who I am. So a checkout knows about who rented it, right? And that person, members belong to a county. So here's me checking out Harry Potter. Harry Potter's book 1. I am person 1. I'm going to rent it today. The due date. And maybe due date's a programmatically filled out category that just calls start date plus 2 weeks, right? Or something like that. So due date is today plus 2 weeks. And that would actually get filled out. I just don't want to do the math. And then when did I actually return it, right, is like another thing that has to happen. So this record is not going to have all of the results filled out when you originally create it. And then later when I come back and check that book back in, they're going to say you returned it today plus 3 weeks or whatever, whenever I ended up renting it. And then at that point, you'd probably have a method when you updated the return date that would say something like return date minus due date, right? And if that's a positive number, it's late, right? And then maybe you'd say number of days times a fixed cost per day, and that would calculate maybe a late fee. Right, and again, that would be programmatically calculated. And when I returned it, you know, it'd say you owe $1.34. And then maybe you'd even add like something like amount paid, right? So when I return it, did I pay anything, right? Maybe I only had $1 on me, I paid that. Maybe you have another field also that may be programmatically calculated and that we sort of cache that says amount owed. Right, and that would be the difference between the late fee and the amount paid. I like to live dangerously. I'll grab a.
He made it.
You had a question?
Yeah. So like, don't books need to know they've been checked out?
Do books need to know they've been checked out?
Because I was thinking like, if you want a book, you don't want to find out if you have the book, is it checked out or not. So I don't know where that belongs. Does it belong to checkout or does it belong to the book? I mean, do you associate that on the book or associate that with the checkout?
Well, let's try it. So we could put it on book, right? And we could say, so we'll call it checked out, Boolean. So Harry Potter is checked out now. Which copy of Harry Potter is checked out? The only copy? So it doesn't belong here, right? Because this would mean all copies of Harry Potter are either checked out at once or not. So
Library.
yeah, so I think it belongs under checkout. We're keeping track of which book got checked out, but this again, this points to a book, right? So this is just as bad as my other solution, right? So I just put checked out Boolean. That's essentially what I'm doing here, right? I'm saying this row refers to this row in the table. So if I try and say, you know, is Harry Potter checked out? I'm going to look in here and I'm going to say, are there any rows in the checked out column where has book ID 1? And I will say yes. So this is just as bad. So you just pointed out like a flaw in my logic. So it's not that a checkout relates to a specific book. It's that it's got to relate to the physical copies right? I want to know like which copy of Harry Potter is being checked out. So probably what I would need to do is keep a little more information on this table and give this stuff an ID and make this like a real entity and say this is 1, 2, 3, 4, right? So this is Harry Potter in Cobble Hill. This is Harry Potter in Brooklyn Heights. This is Harry Potter in Queens. This is Harry Potter in Sunnyside. So when I check out a book, I need to know not that it's just Harry Potter, but which physical copy, right? So this really should be physical copy ID. And that should point to, I took out the Harry Potter in Cobble Hill, right? And probably libraries even have multiple copies of Harry Potter, which I would keep track of in physical copies. And I'd say, Harry Potter, we could have multiple at Cobble Hill, right? But the checkout would be related to a specific row in this table. And that way we always know at any individual library which of the, like these actually represent physical books that are on a shelf somewhere, each of these rows. So when I check out a book, I want to say it's that book, right? There is a specific one I took out. There was 4 copies before, now there's 3. So to me, it's like very much on the checkout that I want to keep track of it. You could theoretically keep track of it here. So we could say, you could call this checkout ID, right? And we could have this point to the other thing. This just feels wrong to me though, because physical copies are probably going to be having like specific qualities to them. And so if I do it this way, I'm going to say physical copies belong to a checkout. So this is me checking out the Harry Potter in Cobble Hill. And let's say I want to check out the Harry Potter in Cobble Hill again. What does that look like? How do I do that? I can't, right? Because I just have to like change this. Like I could only, this is Harry Potter in Cobble Hill. There's only one of them that exists, one row that exists anywhere in our domain. So if I want to say, I want to be able to check out this multiple times, if it sits here and it's belonging to a checkout, it can only ever belong to one checkout. Unless, again, I start repeating it, right? And I say, okay, actually, there's another row that represents Harry Potter in Cobble Hill, and it's number 6, checkout ID number 6. And this just feels super weird to me, like I'm repeating stuff. To me, physical copies have many checkouts. They don't belong to a checkout. So this stuff is hard, but I think this way of doing it makes things a lot more clear. Like every time you think about a table, you just have to think about like, okay, what is the stuff that I need to keep track of here, right? And as you start trying to figure out who should keep track of which is has many and which just belongs to, and which is, if it has many, I just try and like add actual things, and to me it feels like pretty obvious as soon as I have to start repeating stuff that my schema doesn't work, or I can't ask my database the questions that I want to be able to ask it. And I think when you talk about actual instances of these things, it becomes so much more clear, and it's really hard, specifically at the stage you guys are at, to talk in the abstract. Has many, belongs to, it doesn't really mean that much. But I do think talking about it is useful when you're speaking about specifics. Other questions about this stuff? Examples you want to play with? Anything else? And I just took topics out. Topics are going to work the exact same as genre, but I think topics are less obvious than genre, because I don't really think of books as having topics as much as like genre is something like we're all pretty intimately familiar with, but it would be the exact same.
Could you show a has many belongs to relationship?
Yep, there's a bunch in here. Let me write them all out. County has many libraries. Library belongs to county. So anytime it's has many belongs to, has many doesn't have a foreign key, belongs to does. So anybody with a foreign key belongs to somebody else, and then that thing has many of it. So these guys belongs to book, belongs to library. Member has many, what? I don't know if members have many anythings. Oh, they have many checkouts. Right, 'cause people are going to be checking books out. Do they have them directly? Yes. So members have many checkouts, and checkouts belongs to member. Members have a county ID, so they belong.
Because there is an association that is called has many belongs.
Yeah. Has and belongs to many we don't use. That is an old thing. Yeah. Well, no, it still works, but we don't use it anymore.
Which one? Sorry.
Has and belongs to many we don't use anymore.
Can you read that?
Yes. If you has and belongs to many, you can't have anything on a join table more than just the two belongs to keys. But very often on the join table, you want to keep track of other stuff. So if you use has and belongs to many, and you decide later to keep track of anything else, you can't. So if you use has many through, and you use this as the join table, you can add as many things you want to the through table. So it's just artificially limiting, and so people stopped using it in like Rails 2 or something. But it still technically works. So just don't use it. Okay, so member has many checkouts, belongs to county. Books has many book authors, has many authors through books, through book authors. Book authors belongs to author, belongs to book. Author has many books. Nope, has many book authors and has many books through book authors. A checkout belongs to a member, and it belongs to physical copy. Genre has many books. There are probably other through associations I'm missing. Library has many physical copies. Library has many books through physical copies.
Something I never fully got with through is what is through doing exactly? Is it for has many books through physical copies?
Mm-hmm.
Is that putting a foreign key for physical copies in books?
Has many does not put foreign keys in anything. None of the associations do anything. We design the database, we run the migrations, and then what has many will do is it will write SQL for us that assumes that we have put foreign keys somewhere. So what the through association says is, first thing I want to do is I want to do a join to physical copies. So I'm a library. I want to know what physical copies I have. So I'm assuming there is a table called physical copies, and it has a foreign key that points back to me. So that active record can generate this SQL. Select all from physical copies. And then join, select all from libraries. Join physical copies on library.id equals physical copies.library.id. So it puts those two tables together, right? And the through is, at the end, I want to get books, right? I know that I have these physical copies, but all I really want to know is like, what are the books? Give me the list of books. So now I have to join the books table to the physical copies table. Physical copies has a book ID, right? And that's going to be equal to the books ID column. And now that puts all of the tables together. Although, sorry, we said we wanted books, so my select should be from books, so that I end up with books. And I'm going to need to join, not books, but I need to join myself. Join libraries on physical copy dot library ID. Oh, it's this one up here. So I'm selecting all from books, and then I need to join books.id on, oh, I didn't delete it, books.id on physical copies, book ID equals books.id. So I'm saying put these three tables together. So first, take the books table and put it together with this table because this is the key. And then join on the libraries. And the thing that I want returned is the books. So if you had to write the SQL for this every time you wanted to ask a library all of the books that it had, this would be super annoying, right? So the whole point of these associations is that these will dynamically generate methods for you. So now I can say library equals library dot first, and I can say library dot books. And then isn't that easy? Right? I just call the books method on a library object and it will run this SQL for me. And it can only run this SQL if you have set up your tables in the database in the way that it expects, because this is the SQL it will generate. And the whole way the magic works is if you follow the convention and Action Record follows the convention, then the SQL that it generates will magically find the right stuff. If you don't set up your tables like this and you call this house ID, right, it's going to blow up because it's going to say, why did you call that column house ID? There's no column called book ID. I don't know how to find this thing. And that's where you can say, hey, like, I actually want to call this thing a different thing. So I have many physical copies, but the foreign key, you were assuming it was going to be library ID, but actually it's house ID, right, or something like that. And you can tell I changed from the convention. So when you generate your SQL, use this rather than that. Other questions? All right, cool. So we'll do some more of this tomorrow. Hopefully this will sink in a little bit, and then when we do the second round tomorrow, we'll be closer and we can get at some trickier questions.